According to NEC 240.4, the ampacity of the conductors must be equal to or greater than the rating of the overcurrent device protecting them. This means that the wires you choose must be able to safely handle the amount of current that the circuit breaker or fuse is designed to allow. Let's consider the situation of using a 1600 amp switchgear with 6 breakers and no main breaker, and whether you can run 3 sets of 500 kcm conductors to the service equipment. The answer is no, you cannot, and here's why. NEC 240.4 is clear. The ampacity of your conductors must equal or exceed the rating of the overcurrent protection device. In this scenario, the overcurrent device is the 1600 amp switchgear. That means the conductors need to have a minimum ampacity of 1600 amps. Now let's look at the ampacity of 500 kcm copper conductors. According to the NEC tables, specifically table 310.15b16, the ampacity of a 500 kcm copper conductor, when installed in a typical raceway or cable, is 505 amps. If you run 3 sets of these 500 kcm conductors, the total ampacity would be 3 times 505 amps, which equals 1515 amps. Comparing this total ampacity of 1515 amps to the 1600 amp rating of the switchgear, it is clear that the conductors do not meet the minimum ampacity requirement set forth in NEC 240.4. The conductor's combined ampacity is less than the rating of the overcurrent device protecting them. To further clarify, let's consider why this rule exists. The overcurrent protection device, such as a circuit breaker, is designed to protect the conductors from overheating and potentially causing a fire. If the conductors are undersized for the amount of current flowing through them, they can overheat, damaging the insulation and potentially leading to a short circuit or a fire. Therefore, the NEC requires that the conductors be sized appropriately to handle the maximum current that the circuit breaker or fuse will allow. Going back to the example, the 1600 amp switchgear is designed to trip if the current exceeds 1600 amps for a sustained period. If you were to use conductors with a combined ampacity of only 1515 amps, they could overheat before the circuit breaker trips, creating a dangerous situation. So, what are the alternatives? If you need to supply 1600 amps to the service equipment, you'll need to use conductors with a combined ampacity of at least 1600 amps. This could involve using larger conductors, such as 600 kcm or 750 kcm, or using more sets of conductors in parallel. For example, you could use 4 sets of 500 kcm conductors, which would give you a combined ampacity of 2020 amps, exceeding the 1600 amp requirement. However, when running conductors in parallel, there are additional requirements that must be met. Firstly, all conductors must be the same length. Secondly, they must be of the same material. Thirdly, they must be the same size. Fourthly, they must have the same insulation type. And fifthly, they must be terminated in the same manner. These requirements are in place to ensure that the current is evenly distributed among the parallel conductors. If the conductors are not properly installed, one conductor may carry more current than the others, leading to overheating and potentially creating a fire hazard. It's also important to consider the termination ratings of the equipment. The terminals in the switchgear and the service equipment must be rated for the size and number of conductors being used. If the terminals are not rated for the conductors, they can overheat and fail, creating a dangerous situation. When selecting conductors, it's crucial to consult the NEC tables and ensure that you are using the correct ampacity ratings. The ampacity of a conductor depends on several factors, including the conductor material, the insulation type, the ambient temperature, and the number of conductors in a raceway or cable. The NEC provides tables that list the ampacity of various conductors under different conditions. It's also important to consider any derating factors that may apply. For example, if the conductors are installed in a hot environment, the ampacity must be derated to account for the increased temperature. Similarly, if there are more than 3 current-carrying conductors in a raceway or cable, the ampacity must be derated to account for the heat generated by the conductors. In summary, NEC 240.4 is a critical safety requirement that ensures conductors are adequately sized for the overcurrent protection device. When sizing conductors, it's essential to consult the NEC tables, consider any directing factors, and ensure that the conductors and terminations are properly installed. Failing to comply with these requirements can create a dangerous situation and potentially lead to a fire or electrical shock. Remember to always consult with a qualified electrical professional when designing and installing electrical systems. They can help you ensure that your system complies with all applicable codes and standards, and that it is safe and reliable. Understanding the NEC is crucial for anyone working with electrical systems. It is a comprehensive set of rules and regulations designed to protect people and property from electrical hazards. While it may seem complex, the NEC is based on sound engineering principles and years of experience. By following the NEC, you can help ensure that your electrical systems are safe and reliable. When working with electricity, always prioritize safety. Wear appropriate personal protective equipment, such as gloves and safety glasses. De-energize circuits before working on them whenever possible. Use insulated tools and equipment. And never work on electrical systems if you are not qualified to do so. Electricity is a powerful force, and it must be treated with respect. By following safety precautions and complying with the NEC, you can help prevent accidents and ensure that your electrical systems are safe for everyone. Let's reiterate the key points about NEC 240.4 and conductor sizing. The ampacity of the conductors must be equal to or greater than the rating of the overcurrent device. The ampacity of a conductor depends on several factors, including the conductor material, insulation type, ambient temperature, and the number of conductors in a raceway or cable. Directing factors may apply, such as for high ambient temperatures or multiple current-carrying conductors in a raceway. When running conductors in parallel, all conductors must be the same length, material, size, and insulation type, and they must be terminated in the same manner. The terminals in the switchgear and service equipment must be rated for the size and number of conductors being used. Always consult the NEC tables and a qualified electrical professional when designing and installing electrical systems. The purpose of the overcurrent protection device, such as a circuit breaker or fuse, is to protect the conductors from overloads and short circuits. Overloads occur when the current in a circuit exceeds the ampacity of the conductors, but the current is not high enough to cause an immediate short circuit. Short circuits occur when there is a direct connection between two conductors of different polarities, resulting in a very high current flow. In both cases, the overcurrent protection device is designed to interrupt the flow of current before the conductors overheat and cause damage or a fire. The rating of the overcurrent protection device should be selected based on the ampacity of the conductors being protected. If the overcurrent protection device is rated too high, it may not trip in time to protect the conductors from an overload or short circuit. If the overcurrent protection device is rated too low, it may trip unnecessarily, causing nuisance tripping. It is important to select the correct rating of the overcurrent protection device to ensure that the conductors are properly protected and that the circuit operates reliably. In addition to NEC 240.4, there are other NEC requirements that relate to conductor sizing and overcurrent protection. For example, NEC 310.15 specifies the requirements for determining the ampacity of conductors. NEC 240.3 specifies the requirements for protecting conductors against overcurrent. NEC 250 specifies the requirements for grounding and bonding. It is important to be familiar with all of these requirements when designing and installing electrical systems. Grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to flow back to the source, allowing the overcurrent protection device to trip and to energize the circuit. Bonding connects all metal parts of the electrical system together, creating a low impedance path for fault current. Proper grounding and bonding can help prevent electrical shock and fire hazards. When working with electrical systems, it is important to use the correct tools and equipment. Use insulated tools to prevent electrical shock. Use a voltage tester to verify that circuits are de-energized before working on them. Use a clamp meter to measure current. Use a multimeter to measure voltage resistance and continuity. and always follow the manufacturer's instructions when using tools and equipment. Regular maintenance is essential for electrical safety. Inspect electrical systems regularly for signs of damage or wear. Replace damaged or worn components. Tighten loose connections. Clean electrical equipment to remove dust and debris. And test overcurrent protection devices to ensure that they are functioning properly. By performing regular maintenance, you can help prevent electrical problems and ensure that your electrical systems are safe and reliable. Remember to always prioritize safety when working with electricity. Wear appropriate personal protective equipment. To energize circuits before working on them whenever possible. Use insulated tools and equipment. And never work on electrical systems if you are not qualified to do so. Electricity is a powerful force, and it must be treated with respect. By following safety precautions and complying with the NEC, you can help prevent accidents and ensure that your electrical systems are safe for everyone. Always remember to consult the latest edition of the NEC for the most up-to-date requirements. Electrical codes and standards are constantly evolving to reflect new technologies and best practices. Staying informed about the latest changes is essential for ensuring that your electrical systems are safe and compliant.